Okay, let's move on to case 2. So we're going to take this example to find out what case 2 means. So first we need to break down that denominator. So sometimes the denominator will be factored for you, and then other times you have to see if it can factor. So we have x plus 2 on the top, and on the bottom, looks like we have an extra x there. So a GCF of x should be factored out the front. Then we have x squared minus 2x plus 1. And we should see if that will factor. So that's x plus 2 over x times. Now I'm thinking this is x and x. And then we need a positive 1 to multiply, and we need to add to negative 2. So that could be minus 1 and minus 1. Negative 1 times negative 1 is positive 1. And when we add those terms, we get negative 2x. Okay, so what we have here is x plus 2 on the top. On the bottom, we have x. And then notice x minus 1 times x minus 1 would be x minus 1 squared. This is a repeating linear factor. Remember on the other case, it was the non-repeating linear factors. So case 2 is actually that the denominator has a repeated linear factor. Okay, so to set those up, let's start with the problem. X plus 2 over x times x minus 1 squared. We're going to break it down in the same way, a over x plus, but when we have these repeated linear factors, we're going to have a couple more terms. So we're going to have a b over x minus 1, and then we're going to have another fraction, c over x minus 1 squared. So with the repeated factors, you have to keep repeating them until you get to that exponent. So like, let's say if it was x minus 1 cubed, we would have these two terms, and then we would also have d over x minus 1 cubed until you get to that exponent. Okay, so that's why we have an extra, and that's just the pattern that these fractions always break down into. They always break down into 3 fractions, and these are the denominators. Okay, but now from here on, I think the process it can be pretty similar. And definitely this first step is the same thing that we've been doing. Multiply by the denominators. So we want to multiply by x times x minus 1 squared. Okay, on the left, that gives us x plus 2. On the right, each one kind of takes out part of the denominator, or part of this extra term, right? So a times x minus 1 squared plus b times, we're going to have, this one is x and x minus 1. And then this one is c, and then the x minus 1 squareds are both gone, so it's just cx. Okay, so great. So far, we've actually been doing the exact same process, but I want you to take a look at that now. Okay, we can do the process the same. We can continue making a system, but what we would have to do, we'd have to FOIL this, then we have to combine all our like terms, multiply this out, then we'd have to combine all the x squared terms, all the x terms, and all the constant terms. Right? And then because there's a, b, and c, there's actually, it'd be 3 equations, 3 unknowns. It's totally doable. You can still do it that way and use the same process that we've been doing. Notice over on the left, the x squared would be equal to 0, that equation. The x equation would be equal to 1, and the constant equation would be equal to 2. Okay, make sure you've watched the other 2 videos before you watch this one if that doesn't make any sense. Okay, so you can do it that way, but I'm here to show you in this video the other method. Okay, so this is like kind of method 2, and I kind of like this method. It can be really quick and it's kind of clever. Okay, so take a look at these, this side of the equation. A is times x minus 1 squared. B is also times an x minus 1, and C is not. So what we're going to do is make clever use of what x might equal. So let x equal 1. Okay, and see what happens and see why I chose 1. Okay, I just picked 1. I picked it for a certain reason, so I want you to try to figure out why I picked 1. Okay, if x equals 1, this side of the equation is 1 plus 2. This side of the equation is a times 1 minus 1 squared, right? That's times 0. 0 squared is still 0. Plus b times 1, but then this is 1 minus 1, so that's times 0, plus c times 1. Okay, so in other words, the left side is 3, a times 0 is 0, b times 1 times 0 is 0, and then plus c times 1, so just c. So do you see? We figured out that c has to equal 3. Okay? All right, now what if we set x equal to 0? Okay? And I'm going back to my original equation that I came up with, this equation right here, right? Okay, now I picked 0 on purpose as well. I think it's going to be really helpful too. All right, so this would be 0 plus 2 equals a times 0 minus 1 squared plus b, times 0 minus 1, just 0 minus 1, plus c times 0. You can put in the 3 if you want. It doesn't really matter because it's going to be times 0. Okay? All right, so now you can see 2 equals a times 0 minus 1. Now, negative 1 squared is a positive 1, so this is just a, or a times 1, plus b times 0, whoop, that's 0, and 3 times 0. Okay, so we just found out that a is 2. Well, that's good news because now we know c and a, so all we have to do now is find b. To do that, we're going to do the same process. We're just going to pick another number for x. Now, I really on purpose, I picked 1 and 0. I think you probably know why, right? Because then that kind of made some of the terms 0. When I'm choosing to find b, I can't pick 0 and 1 because I keep losing that b term. I can really pick anything else, okay? So I usually just pick like 2, okay? So, and we're going to plug in what we know is a and c this time. Then we'll be able to solve for b, okay? So if x is 2, that would be 2 plus 2 equals, I'm just going back to this original equation here, okay, every time. A, which was 2 times 2 minus 1 squared, plus, we don't know what b is, but we do know it's times 2 minus 1, and then plus c was 3 times 2. Okay, let's see if I can just gotta scooch this down just a little farther. So that's 4 equals 2, and then 2 minus 1 is just 1 squared. So that's just 2 plus, that's 2 times b plus 6, right? So I'm seeing 4 equals 8 plus 2b. So 2b equals negative 4, 4 minus 8, negative 4, and b is equal to negative 2. Okay? Remember, all we were trying to do was find a, b, and c. So it is a really kind of weird, unique technique, letting x equal a number, right? But we can do that. I mean, not that x can really equal that in the original equation, but once we've cleared the fractions, it really could equal any number. So, you know, we're just finding convenient numbers for x that help us find our goal, A, B, and C. So now I've used up so much paper. Let's see if I can go back to the original problem. And so B is -2. I have to remember this. Let's see. Oh, there's the problem. Okay. Okay, so our answer in the A, B, and C, A was 2, so it's 2 over x, plus B was -2, so -2 over x minus 1, plus C was 3 over x minus 1 quantity squared. Okay. So I hope you noticed that that method was a little bit different than solving the system per se. So those are the two methods. And like I said, I'm going to continue to kind of do both methods in the practice problems so that you can get really comfortable with both ways to do it.